In this video, we are going to look at how to add vectors graphically. Graphically means visually. We are going to be adding the arrows tip to tail to see what our resultant vector is going to be. So when you sum vectors, it doesn't matter how many you have. Let's say we're dealing with force vectors. So force vector 1 plus force vector 2 plus force vector 3. We could add all the way to force vector 100 if we wanted to. All of these vectors are going to have their own magnitude, that's to say their own length of the arrow, and they're going to have their own direction. Okay, they're going to have an angle. When we sum all of these vectors up, we're going to be left with what's known as a resultant vector. The resultant is going to have its own magnitude and its own direction, and that is going to be the result of adding all of those vectors. Now it's important to note that you can only add like vectors. That means you cannot add a force vector to, let's say, a velocity vector. It just can't be done. But you could add velocity vectors to velocity vectors. So we're going to look at graphically adding or drawing out vectors to determine the resultant. Now, you're going to need, in order to do this, in order to measure out magnitudes and direction, you're going to need a protractor and a ruler. Because the distance of the actual, or the length of the actual arrow, is going to be the magnitude of your vector. And the direction of your arrow is going to be measured using a protractor. So let's say we have two vectors. We'll say that this is vector 1, and we want to add it to another vector. Let's say we will use this vector here as vector 2. Now if we want to add these graphically, what we have to do is we have to draw them tip to tail. The first vector is going to be the starting point. And the starting point on that vector is going to be anywhere, okay, or it's going to be at the tip, sorry, not anywhere, at the tip of the actual, or the tail of the actual vector. So this is the start. Now, the end point of this addition is going to be at the tip of the second vector. The second vector in this situation is right here. So when we add these to determine what our resultant is, we're going to be going from the tail of the first to the tip of the last. This is your finish point. Now, we're going to move some things around here, and I'm going to show you. Otherwise, we would just redraw it freehand. But we're going to try and move these around. Now, if I take this green vector here, I'm going to go and I'm going to place it to the top of the first arrow, like so. Now, what we have to do is we have to actually link these vectors. And by linking these vectors, we're going to get our resultant. So we start at the starting point, and our arrow is going to go and it's going to reach the tip of the finish point. So here we've got our first vector, so v1 plus v2 is going to give you vr, or v resultant. This actual vector is going to have its own magnitude and its own direction. Now, I'm just going to go to another page here. Let's try 4 vectors. Okay, let's try 4 vectors pointing in 4 different directions, and let's see what we get. So we're going to start off with vector number 1, vector number 2, vector number, let's say, 3, and vector number 4. No idea what this is going to give us. But let's try and sum all of these, okay, or add them, and let's see what we would get with our resultant vector. So we're going to move these around and see what kind of pattern we can get here. So we'll start off with this guy right here. And then we will move this guy, his tail, to the tip of the first. Then we will tackle this big guy here. And again, we're going to go to the tip of the last vector we just added, and we're going to attach this one. And then finally, we're going to go to this little vector, and we're going to place it on the end here. Now, you'll notice that this works out almost beautifully in that we've got a nice, clear path, if you will, to our resultant vector. So our resultant vector is going to start at the actual tail of the first vector, so this is our start point, and it has to finish at the tip of the last vector. This is our end point, or our finish line. So we will start our arrow down here, and we will go towards the tip. So this is going to be our actual resultant vector, okay? Now, if we're doing this mathematically, if we're adding vectors graphically and mathematically, because you will always use a graphical sketch to kind of prove your work. And in certain questions, you will be asked to draw out to scale whatever you've calculated mathematically. We're going to get into the calculations in the next video. But in this case, drawing vectors out, drawing the addition of vectors out graphically is a really good proof of your work. It gives you an idea of where this vector should be, so that when you actually calculate it using trigonometry, you can see if they both add up, and they should. If they don't, that means you've done something wrong. Now, the only time that this idea of direction going from the tail of the first to the tip of the last doesn't work is if a question might ask you, well, how far away is so-and-so from the starting point? Well, in this case, they want to know, the distance between the two, and they want you to be pointed in the opposite direction. So all you would have to do is determine the direction of your resultant and flip it 180 degrees. Okay, we'll get to an example like that when we calculate mathematically. Next video is going to look at the component method of vector addition.